Hello guys, trust you're doing fantastic. In today's video, we're going to be talking about the 2's complement subtraction. Now let's go straight into case 1. Subtraction of smaller number from larger number. Now in this scenario, it means we're going to have the large value minus the small value. Now let's go through the rules. The first rule says we need to get the actual binary, which I'm going to abbreviate with AB, of both the minuend and the subtrahend. Now the second rule says take 1's complement of subtrahend and the 2's complement as well. The third rule says add it to the minuend. The fourth rule says if carry is generated, discard the carry. Now this is a very simple procedure because we're minusing or we're subtracting a small value from a large value. So it means this fourth rule, it's gonna be as easy as this. Note that the structure for subtraction is minuend minus the subtrahend. The subtrahend is nothing but the value that is to be subtracted from the other value. Alright, so the minuend is actually the value that is subtracting the other value. Now let's go straight to a very quick example. Now example says what is the 2's complement subtraction of 28 from 48? So it means that we're going to be subtracting 28 from 48. So in this case, 48 is the minuend and the 28 is the subtrahend. So that is the first thing you need to do. You need to identify which one is the minuend and which value is the subtrahend. In our case, 28 is the subtrahend. So let's go straight into solving this exercise. Now follow me as I take you through the step. The first step is to get the actual binary of both the minuend and the subtrahend. Now we check the larger number, which is 48. The actual binary of 48 is going to be represented in 16 bits, meaning we're going to have 110000. Now if you don't know how to convert this into binary, please check my previous videos. Now this is simply 2 raised to the power 5, 2 raised to the power 4, 2 raised to the power 3, 2 raised to the power 2, 2 raised to the power 1, and 2 raised to the power 0, which will give us 32, 16, and 0000. Now if you sum up 32 and 16, you're going to get 48. Now let's get the actual binary for 28. Now the actual binary for 28 is actually going to be 5 bits. It's going to be 11100. So it's going to be 5 bits. So 5 bits will be the minimum number of bits required to represent 28. But because of 48, which is larger, has 6 bits. So it means we have to represent 28 in 6 bits so that we can carry out the operation successfully. Because for we to carry out this operation, both minuend and subtrahend should be in the same bit number. So in this case, if you have, this is going to be 16, which is going to be 2 raised to the power 4, 2 raised to the power 3, 2 raised to the power 2, 2 raised to the power 1, and 2 raised to the power 0. Now if you have that, it's going to be 16, 8, and 4. So if you sum everything up together, if you sum 16 and 8 and 4, you're going to get 28. So you're going to have 16 plus 8, that is going to be 24, plus 4, you're going to get 28. Then you have 0, 0. Now in order for we to have the same bits number, we have to add one more 0, we have to add one more 0 to the left. So it means that this 0 is not significant. It doesn't change the value of 28. This is the same value of 28. So just add 0 so we can have the same number of bits. Have 1, 2, 3, 4, 5, 6. That will give us 6 bits. Since we have 1, 2, 3, 4, 5, 6, 6 bits. So this is what you need to take care of. Alright? Please follow this step. Let's go over to step 2. Now step 2 says take 1's complement and 2's complement of the subtrahend. The subtrahend is nothing but 28. Now let's take, first and foremost, we know the actual binary of 28 is 0, 1, 1, 1, 0, 0, which is what we got here. Now the next thing we need to do, since 28 is the subtrahend, take the 1's complement of 28. It's going to be to get the inverse of 28. Get the inverse of it. So that is what we mean by the first complement. Alright? So the inverse of it is going to be where you have 0, you have 1. Where you have 0, you have 1. Where you have 1, you have 0. Where you have 1, you have 0. Where you have 1, you have 0. Where you have 0, you have 1. So this is nothing but the inverse. So it's first complement, the inverse. Now once you have this, let's take the 2's complement of 28. The 2's complement of 28 is nothing but adding 1 to the first complement. Now this is the first complement, we need to add 1, right? So we've added 1 plus 1. So let's go. 1 plus 1 is going to be 0 with a carry of 1. So we put that carry, which is this red ink. We say 1 plus 1 is going to be 0 with a carry of 1. So add the carry to this part, which is the second red ink, indicated by this second red ink. Now 0 plus 1 is going to give us 1, and then you have 0, bring down the 0, the other 0, bring down the 0, and then the 1, bring it down. So you're going to have this new result as the 2's complement of 28. Now once you've done that, it means you are already getting close to the final answer. Now let's go over to the third step. The third step says add the result to the minuend. The minuend is the 48. So let's add the result to the minuend. Now this is the 2's complement of 28, which is this. Write it out, which is 1, 0, 0, 1, 0, 0. This is it. Now let's add this result to the actual binary of 48, which is the minuend. Now if you remember, our actual value for minuend is this 1, 1, 0, 0, 0, 0. This is 48. Now let's carry out the summation. 0 plus 0, 0. 0 plus 0, 0. 1 plus 0, 1. 0 plus 0, 0. 0 plus 1, 1. 1 plus 1, we're going to have 0 with a carry. Now the red ink here indicates the carry. Now since you don't have anything at this point, you just bring down the carry. You have 1. So you're going to have 1, 0, 1, 0, 1, 0, 0. So in this case, carry is generated after the final result, which is this. Now let's go over to the fourth rule. The fourth rule says if carry is generated, discard the carry. So since carry is generated after the summation of the last bit, we have to discard it. Hence, the result will be 0, 1, 0, 1, 0, 0. So this will give us the result also in 6 bits. Alright, so we're going to discard this carry. We're going to be left with this result. So this is what we have. And then if you convert this binary into decimal, you're going to have 20. Because what you have here is actually 1, 2, 3, 4, 5, 6. So you have 16, you have 0, and then you have 4. So 16 plus 4, you're going to have 20. Right. So if you do that to the original question, it's going to be the same. If you have 48 minus 20, if you have 48 minus 28, you're going to have 20. So it means what we have done is correct. I'm going to encourage you to pay attention to the subsequent videos in this channel. Alright then, enjoy this video. Bye.